Hi everyone, this is Chris, and this is the second day of the 10 days challenge where I'm building an app from scratch and I'm sharing everything. And in this video, I'm gonna show you the progress that I did yesterday, and because I focus on the pitch prediction. Okay, I think that is one of the most challenging part of the project, like in my opinion. Um, but I did a pretty good progress, and I'm gonna show you now. As you can see here, I have this simple web app, which is only a button. And when I click the button start, it starts the prediction, right? Which, as you can see here, it is predicting any sound, right? Like it could be a clap even. Yeah, it's supposed to be a. It could predict your voice as well, like yeah, my intonation is not great, but as you can see, it is predicting my voice. So let's try that with an instrument now. I have my violin here, so I'm gonna play A. Now I'm gonna play G. Now I'm gonna play D. As you can see, it's predicting pretty accurate. And if I play a song, let me play that song real quick. Let's see how it goes. This is very uncomfortable. Hold on. It is predicting every single note. And it is amazing. It's really accurate. I'm so impressed with the results. So now, technical details, how I was able to do this. Well, the first thing I needed to do after clicking the button, the first thing we need to do is basically to request access to the microphone. Okay, so there are APIs already in JavaScript for that. We just need to call the navigator, media devices, get user media. We send an object of parameters with the video equals false because at least for this project, I really don't need the video. I only need the audio. Audio equals true, and then this returns a promise. It is a promise because the user needs to accept the permissions, and that might take, I don't know, whoever amount of time the user takes to click the allow button, right? So once the user clicks on that button, then we will get the string, and this is the piece of data that we need and that we are going to send to the algorithm that is going to predict the pitch, right? Now, when it comes to pitch detection, I stumbled into this library called ML5JS, which is a machine learning library that allows you to basically use neuronal networks, classifiers, extractors, like many things in here. And as you can see, we have like APIs for images, like face recognition and like other things. It's pretty awesome. And we have sound, and the sound has like pitch detection. This library, guys, like I did a lot of research, and this is the one that I find out that it was pretty accurate and it was so easy to use. As you can see here, this is how we can use it. We create the audio context, and then we get the stream basically from from this API right here, this stream, this one. We can send it to the pitch detection method, the stream, the audio context, the model. This is basically the files, the training files that we need to send. Like when we check out this library, we're gonna get all those files as well when we install this library in our project. Then we send like a callback method that this is going to be executed when the model is ready to start predicting. And finally, when everything is ready, we call this method get pitch, and we are going to get the frequency. And now, once we have the frequency of the sound, we can map that frequency with a MIDI value. Okay, a MIDI value is basically a number that represents a note in the music scale, right? Like C, D, E, that kind of thing. And after that, the only thing it was just to render that value. Okay, so let me show you an example of here. Here's some code, and Let me click the play. And yeah, this is the pitch detection piano. It is example from the library. I use this code to come up with mine. So I'm gonna play a G. See, in the piano, like this note right here, this one is G, and it highlights when I play G. Now I'm gonna play A. Yeah, now D. Oh, that's G. I'm sorry. D is this one. D and E. Yeah, you see, as you can see, it is predicting pretty accurately. So this is the library that I use, and they have like the GitHub coding here. Um, as you can see here, this is all the code. As I was telling you, we need to map each frequency with the label of the node. And this is the code, basically what it is, setup, yep. Basically create the audio context, get the user media, and we get the stream. Once we have the stream, we start the pitch. This is, pitch detection. We send the models, audio context, the stream of the microphone, and then model loaded, which is a function once that is going to be executed when the model is loaded so that we can use it to start predicting. And then the pitch, we call the function get pitch, pitch.get pitch. And this one receives the frequency. And now there's a function that is called frequency to MIDI. And this is the function right here. Basically, we get the frequency divided in, divide this number against 440. 440 is like the baseline for when it comes to music. It represents A. It's like a, it's like that specific note. So we use that as a reference, and then it basically we do some math. Like honestly, I don't fully understand the whole math involving here, but it's basically translated a frequency to a meeting number, and then it will just return that number, that meeting number. Once we have that number, we can even like look for MIDI numbers or something like that. MIDI frequencies. Here it is. I think, yeah, this is the actual link that I use. Yes, this is the one I use for my app, which 127 represents G9, 43 represents G2, and so on and so forth. 21 represents A2, and the frequency, yeah, this is the frequency. I was telling you about the 440 frequency. That one should, yeah, this one, see, it's A. 49 A4. And this is like a magic frequency, I guess, because you'll find this frequency in many places, like in the real world. It's so amazing how music works. But anyway, this is how I did it. As you can see, I don't want to spend. One of the mistakes I did in previous projects that I work, it was, spending a lot of time in tech, in coding. Now for this project, I'm not going to reinvent the wheel. I'm gonna use whatever it is out there to use it. If it's free, awesome. If I need to pay whatever, I'll pay. Obviously, if it's not that expensive. But anyway, this is it, guys. I hope you learned something. I learned so many things from this project, and I'm so excited that I finally have this working. And see you next time. Bye.